This is a Panasonic SA-BTT490. This is a Blu-ray and home theater player. So the problem in this one, let's plug it to the power. Alright, that's the power button. As you can see, it said hello. So the disc start spinning, then it's go off. So that's the problem. The device turned on, said hello, disc try to spin, then goes off. So quick check, you can see some brownish close to this transformer, and there is some marks on this amplifier board. That's the speaker's output, and this is the home theater amplifier board. And plus we can see there is some cracks in this capacitor. I already put some marks, and the capacitors that's cracked. Yeah, so we have all these capacitors are bad. Basically I'm gonna disconnect this one here, and I will disconnect this board, and we'll see if the device is gonna turn on. Okay, so now the disc starts spinning. And it said read. It stay longer than before. So we have some good change here when we disconnect the sound. Yeah, still not working right, because you can hear the sound. But the good thing is still on, it didn't go off. Yeah, the device is still on. So we have 8 volt here, 8 volt, 8 volt. Okay, let me turn it off. And I'm going to turn it on, and I measure the voltage right here. Oh, I need to keep the... Okay, let me... Yeah, I did see something. You can see the voltage was about like 10 volt and is dropping to the 8 volt. So let's turn it off again. And unplug it. Yeah, we plug it back. And I'm going to check the voltage right here. Yeah, it's the same. So let's do it this way. And I'm gonna press the power button. You can see it's at 11 volt, and it's gonna start dropping. 9 volt, 8 volt. So how much voltage we have here? 36 volt. So this board, it works with the 36 volt. And the voltage here is not stable and is not enough. So could be that 36 volt, it's go to the board, then it's go from this connector, is back to this board to make this 12 volt stable. I'm just guessing. So if I give this, because that one is look like is a 12 volt power line here. Yeah, I see 11.8 volt. So that's a 12 volt line. I'm gonna set up the power supply at the 12 volt. And okay, let's set up the power supply at the 12 volt, and we inject 12 volt to the capacitor. We see if the device is going to stay on and read the disk. Because I don't want to fix this part, then it's not reading the disk or have other issue right here. You can see I put like 11.3. I'm going to plug it to the power. If the power supply is start, there is a load in the power supply about 300 milliamp. The disk is spinning good. And it's the Blu-ray DVD right here. Okay, I'm gonna see if it's gonna start reading it. Yeah, it will. Okay, I'm gonna show you here. Yeah, you can see the time over there. And here the time is start going. It means it's reading now. And it's taking about like 300 milliamp from the power supply. When I take the 12 volt, is the disk which has problem reading. So could be that 36 volt, it's go to this board, then it's go here with the DC to DC converter is gonna be a 12 volt to feed the other component, because the 12 volt that's coming from this board is not enough. And they think, if you look at this power supply, we have this big transformer, and we have this little transformer. This one is for the standby, and could be that's why that standby is not enough to power the 12 volt. So yeah, let's fix this this board. Then hopefully that's the only issue it has. Yeah. So we are going to check this device is a ESR mirror. This one to test the capacitor in the board. I did have this one is a ESR mirror as well, and both of them they can test the capacitor in the board, but this one and this one is supposed to be more accurate and like give a good reading. I was thinking to get this device a long time ago, but just waiting for the right moment. This is not a review like the company shipped the device for me to review it. No, I pay it for this device. And after I test it for like a couple weeks, I'm gonna tell you the results, how it's gonna be. But we can just check this once. These capacitors here, it's a nanofarad, so it's very less than 1 microfarad. I think this is a picofarad. Alright, let's see what's different between the good and the bad capacitor. So, but first let's discharge these big capacitors. Okay, so let's check this one. Is a low ESR. So here the light, it show how many ohm, and here it's the microfarads and the capacitance. Then you see where it's like this capacitor right here is 820 microfarad, so it should be right here close to the 1K, and it should give us like a 0.1 ohm. So this one and the same, this one here, it's good. Then let's check these capacitors. Okay, yeah, it's still green. This one, it's low, like in the limit. This one good, this one good. Good. This one, it doesn't give no reading, its mean is bad. And that one is the one, it's here that I did put the mark, and that one, it has a crack in it as well. So no reading. That one bad. Yep, the capacitors are bad. Yeah, that's the capacitor we're gonna need to replace. Alright, let's check this one. But this one doesn't matter, the polarity is always give you the reading. And this one is, we should put the negative on the negative side, and we should 0.1 ohm, so that's good. Zero 0.1 ohm. But this one's here, I don't think it can be read, but let's see. No, can't read the very small capacitor like this one's here. It just tested like open. Yeah, let's keep open. Yeah, this one it works. It just says measuring like 10 microfarad capacitor and higher. This one is measuring 0.4 microfarad and higher. And you can even measure the picofarads, but it should be giving you like a little bit higher right here. Alright, order the capacitors. You can see some overheat over there. We're going to need to solder all the points. You can see the capacitor is already cracked. Alright, so let's solder some points that it looks from the overheat. The solder looks not right on it, almost cracked. Alright, the capacitor is marked as 474. Is a 0.4 picofarad. So that's the new capacitors. We don't put the capacitors all the way in the board because usually these capacitors get warm and it's going to transfer the heat to the board, so it's better keep them a little bit far from the board. The same as the original one, they don't put them all the way in the board, or else so I did so I installed the board. It's still doing the same. Turns on. Tries to read. Then goes off. The voltage here is the same as the voltage on the pin number 4. You can see 12 volt. And they start dropping. So could be something else wrong with the power board. And that 12 volt is come from this diode. So in this pin, that's 3.3. No. So this diode, you can see 12 volt, and it will drop. So the 12 volt is dropping. Something going on with the power supply. I'm gonna check the power supply and check it. Alright, here, visual check the power board. It looks okay, there is no cracks on it. And if we check the diode, 0.4, and open, this is double diode. So 0.4, 0.1, 0.4, 0.1, 0.4, 0.1. Yeah, I will need to take the diode and check it. It's this one right here. Is a double diode. Yeah, basically we need to have the same reading both sides. So no reading, no reading. 0.4, 0.1. So one side is weak. 0.4. And could be got weak because of this capacitor. When it get bad, they put a lot of load, and you can see that's the 36 volt side, and that's what was getting hot. This is a 12 volt side, and this is a 36 volt. So I'm gonna look for a double diode, replace it, then we'll go from there. Alright, so I find this diode. The two diodes are facing each other here. And this diode is from the car amplifier, it means it will handle more amp. So here 0.4 this side, 0.4 that side. And if we flip, nothing. But this one here, 0.2 this side, 0.4 that side. So we do see 12 volt, but it's dropped. And I don't know how the 36 volt can control the 12 volt. But anyway, that was a weak diode. If this didn't work, the next thing I'm gonna do is I'm gonna get a DC to DC module, and I will take a 36 volt, convert it to the 12 volt, then I will feed the board. Because when the devices go off, the capacitors, the big capacitor, it holds the 36 volt for milliseconds. It's good dropping slow. That's dropping slow. It will hold the 12 volt longer for the main board to stay on. That's if we can't get this board to work. Well, let's see. Alright, let's turn on the... Okay, here we have 13 volt. 13 volt is staying. Is dropping to 11 volt. 9 volt. Then it's go off. So that didn't fix the problem. I already checked the capacitor, I measured them, they checked good. So we are gonna do the next repair is we're gonna get the 12 volt from the 36 volt. Let me see if there is any like micro crack or anything. Nothing. Yeah, the device is going off. Anyway, let's get to the 36 volt. We convert it to the 12 volt, and hopefully that 12 voltage will hold. Because the device, when we give it the 12 volt from the power supply, device turns on, but we need to keep it on until the other 12 volts stays stable. Alright, so we're gonna have that's the input from the module, this one here, and we solder it in the 36 volt. That side is the negative, this is the negative side, and this is the positive side. So I'm gonna keep the same color, black for the negative and the red for the positive. Yep, you can see the light. This light is just because the capacitor is holding the charge. And when we plug it, you can see the light. Okay, let's check how much here we have, 36 volt. Then it will drop just because the device just plugged in. So here it's drop, and let's turn on. So here is the 36 volt, and we are gonna be sure that 36 volt is going to stay. Yeah, the device is still on, even like it's detecting the load in the 36 volt, that's why it's staying on. Yeah, you see, the device is on. There's something here in the audio amplifier board, but I will like to put the 12 volt back over there in case the device is on right now. And here we have 13 volt. I'm gonna get it. 12 volt something, and they will solder it to the 12 volt line that's coming from the pin number 4 right here. So here, that's the module, and let's power it on. Plug the device. Okay, yep, it's go off. It means the 36 volt is not all the time on. It just when we plug the power, it's like the first start. Okay, let's power on the device. So here is the 12 volt, 13 volt, 12 volt, 20 volt, 36 volt. So the board is giving just 12 volt, but this board, it's switching the power from this connector to this connector, from the 12 volt from here to the 36 volt from this connector that's going to the board and going to the main board. That's why we have this 21 volt. So what this board is doing now is just that it holds the 12 volt, because so the first we do have the 12 volt, but the device, it turns off before the board switch to the 21 volt to here. And that 12 volt, it was weak. By getting the 36 volt converter to the 12 volt, we hold the 12 volt long enough for the main board to switch to switch from the 12 volt to this 36 volt converted to the 21 volt. We just do a delay to hold the voltage up for the device to stay on. Yeah, I think it's fixed. Yeah, it didn't go off. Usually it's go off in couple seconds, as I already detected the disc, and is a DVD Blu-ray, is a reading, and here is it ready to play. And here we are going to have 21 volt. It's not hot at all. Yeah, this 21 volt that's coming from this wire, it's not going to do nothing to this one. It's not going to damage it. Yeah, when this device, yeah, it's a normal. It's not hot at all. Yeah, because the input here is a 36 volt. So even as 21 volt is past all these components that come here, is still under the 36 volt that's coming to here. See, 36 volt, and in the output 21 volt. That output is not from this module. That output is from the main board, converting the 36 volt to the 20 volt. Yeah, I'm just gonna put this one somewhere. Plus I wanna put it on the metal to use it as a heat sink right here, and it should be good. I put screw for the module over there. The device is stable, is on and staying on. We have the picture, you can see it's a Blu-ray. I'm gonna press play button. And you can see the picture. Yeah, the sound, it should be from the speakers here. And I'm just gonna use the small speaker to test it. Okay, yeah, the soundboard, it works. Yeah, I'm waiting for the next track to start.
Organic mush.
Alright, yeah, it's play fine and works fine. So yeah, nothing hot here. Yeah, this capacitor in the module, that's a 35 volt. And remember, we measure like 21 volt here. If this capacitor is lower than 35 volt, that time I was gonna change it. But this one, it should be good enough. So this is all for this video. Thank you for watching, and see you again.